RAID is short for Redundant Array of Independent Disks. Originally, the term RAID was defined as Redundant Array of Inexpensive Disks, but now it is usually referred to as Redundant Array of Independent Disks. RAID storage uses multiple disks in order to provide fault tolerance to improve overall performance and to increase the storage capacity in a system. This is in contrast with older storage devices that used only a single disk drive. RAID allows you to store the same data redundantly in a balanced way to improve overall performance. RAID disk drives are frequently on servers but aren't generally necessary for personal computers. So how does RAID work? With RAID technology, data can be mirrored on one or more disks in the same array so that if one disk fails, the data is preserved. Thanks to a technique known as striping, a technique for spreading data over multiple disk drives. RAID also offers the option of reading or writing to more than one disk at the same time in order to improve performance. In this arrangement, sequential data is broken into segments which are sent to the various disks in the array, speeding up throughput. A typical RAID array uses multiple disks that appear to be on a single device, so it can provide more storage capacity than a single disk. RAID devices use many different architectures, called levels, depending on the desired balance between performance and fault tolerance. RAID levels describe how data is distributed across the drives. You will need to be familiar with RAID Level 1 and RAID Level 5. RAID Level 1 is commonly referred to as mirroring, where RAID Level 5 is commonly referred to as striping. Let's take a closer look at each. RAID 1 consists of an exact copy or mirror of a set of data on two or more disks. A classic RAID 1 mirrored pair contains two disks. This configuration offers no parity, striping, or spanning of the disk space across multiple disks, since the data is mirrored on all disks belonging to the array, and the array can only be as big as the smallest member disk. This layout is useful when read performance or reliability is more important than write performance or the resulting data storage capacity. RAID 5 is a RAID configuration that uses disk striping with parity. Because data and parity are stripes across all the disks, no single disk has a bottleneck. Striping also allows users to reconstruct data in case of disk failure. Reads and writes are more evenly balanced in this configuration, making RAID 5 the most commonly used RAID method.